Synthetic data collapse. Synthetic data collapse is the gradual degradation of a model's performance when it is repeatedly trained on too much AI-generated data instead of real-world data. A simple way to picture synthetic data collapse is like photocopying a photocopy over and over. Each generation looks a bit worse, and the errors keep accumulating. When a model keeps learning from its own outputs, small mistakes, biases, and artifacts get reinforced instead of corrected. This is related to distribution shift, where the training data drifts away from the real-world data the model will actually see. Imagine a large language model that starts with high-quality web and curated human text, but later fine-tunes mostly on its own generated answers and synthetic question-answer pairs. Over several training cycles, its writing style becomes narrower, factual mistakes appear more often, and rare edge cases almost disappear from its behavior. In practice, teams see this as a slow drop in benchmark scores and a loss of diversity in outputs, even though they are feeding the model more and more data. Synthetic data collapse matters because modern foundation models rely heavily on synthetic text, images, and code to scale training beyond what human data alone can provide. If the synthetic fraction becomes too high, models can become overconfident, brittle, and less aligned with the real world, especially on rare or safety-critical cases. For ML engineers, monitoring data provenance, maintaining a healthy mix of real and synthetic data, and regularly evaluating against held-out real-world benchmarks is essential to avoid synthetic data collapse.